Hi, I'm Lars. Welcome back to the shop. Another great thank you for everyone that has been subscribing to the channel. Means a lot to me. Helps me keep on doing this. Makes me want to do this more when people are watching what you're doing. This video is going to be about basics of the Masso. Basics of basically doing any CNC stuff. You need to become familiar with homing, probing, knowing the interface, just something that becomes second nature to you. So when you're running code, can you hit that feed hold? Can you hit that escape? What does all this stuff kind of do? I'm not going to get really deep into it because I really want whoever watches this video to actually want to go out and do this on their own. There's a lot of things you can learn from videos, but there's more. You'll get a more in-depth knowledge of it if you actually do it yourself. Say Kung Fu. You go watch a movie on Kung Fu. You might know all of the different things that you can do in Kung Fu. You might watch baseball and know all the averages of every single player out there and become really knowledgeable about baseball. Neither one of those mean that you can do it. Alright, so even though I'm showing you some stuff, please take the time, go out, take an hour or 2 hours and just familiar yourself with, what exactly does this probe do? What happens when I home my machine? Why is it homing my machine that way? Why does it take the Z-axis, then the X-axis, then the Y-axis? Is there a way for me to turn off homing the Z-axis? Maybe I don't want to ever home the Z-axis. Maybe I don't want to home the Y-axis. I don't know. Is there any way to home all three of them at the exact same time? These are questions that we need to find out before we can get into something that we're making on a really expensive piece of wood, or maybe not so expensive piece of wood, but it's something for somebody that for their birthday or whatever, and you're in the middle of it and there's a problem. How do you, oh crap, I broke a bit. What do I do to replace that bit right then and there? How can I get a new bit put in and still continue on the path that I was on? Or do I have to start all over again? So these are things that you should be comfortable with when running a CNC machine or anything else. You should know these kind of things. So let's get to it. When you first boot up the Masso controller, you're going to see these two buttons here flashing. Nothing really works on the machine, nothing at all. Okay, you can't move your axis, you can't do anything until you do an E-stop on the press. Press the E-stop down here on the bottom, which is sitting down here. Now, if you got a spindle like I do, and everybody has mentioned this on the internet, get yourself a block of wood or something, so when you turn off your machine, you're not going to drop this thing to the ground. Don't put it underneath your spindle, just put it on the side like I have right there, because when you hit this button, that could drop. Now mine didn't drop, so that's the first thing you need to do, and then undo the emergency. Personally, I don't think both of these should be flashing. Alright, I think either E-stop needs to be at the top and then home double tap and door closed, or don't flash this until you're done with the E-stop. But E-stop first, then double tap for home. So when you double tap for home, you're gonna see my spindle go up. And then it'll shake a little bit, because it's going to go to the right, it's going to go to the left, and it's going to come toward you. So that's how mine homes. Mine homes X and Y at the same time. But we're going to reset everything real quick here to make it so that you can see how I did that. So the first time going into setup, you're going to get this admin login page. The admin login page, if you click off to the side somewhere, you'll have read access to everything. Okay? Well, you're supposed to. But obviously you don't, because you can't get in. You can just read what's here, and you can scroll this up and down. So you need to bring it to come back up. You can hit Control L which I don't have anything on this page here, but you can have a external keyboard attached to this, I believe, like a USB Bluetooth keyboard, or you could have a be doing this remotely through a computer. I don't do that because there's a lot of dust in this area and I want to stay near my machine. So let's go to F2, back to setup. This will come back up. If you have a Onefinity, I believe they took away the default password, which by the way is capital H, capital T, capital G. No idea what it stands for. Most companies just put the word password there, but you know, maybe they didn't want to do that. But if you don't have a password, you can hit this little carriage return button right here on the bottom, and now you have the ability to go into homing or wherever you want to go. So when you first come in to homing, you just double click on the homing over here. So in order to get into homing, you double click on homing. When you first come in from right out of the box, your sequence 1 will be Z, because that raises your spindle up. Sequence 2 will be X, it brings it back to the left. And then sequence 3 will be Y, I'll bring it back to the front. I don't know why I've got this down here, I must have tapped it with my finger. Directions of inversion are X, Y, and B. Now, one thing you need to keep in mind is Y is the rail on this side, B is the rail on that side. They have to be inverted the same way. If you unclick this, which I don't know why you can, but maybe it's for plasma or lathe or some other type of machine that the Masso works on, your gantry on the B side will go this way, and your gantry on the Y side will go this way, and the X bar in the middle will get all cockeyed like that. We don't want that. That's bad. That can damage your bars. It can get everything out of whack, mess up your stepper motors. So always keep these two together. Homing feed is 30 inches per minute. The pull-off distance we'll get to in a minute, and your home position could all be zeros, or what I have mine is a 1/4 inch and a 1/2 inch, so it slows down and doesn't, you know, ram into anything for the home. Plus I've got a screw down at the bottom I don't want to get into. One thing you need to notice about these values here, these are check boxes, so having your labels off to the right is just fine. But when you get down here, these are entries. Usually your labels are on the other side. So be careful that when you're putting in Y, you're not putting it over here, you're putting Y over here. Alright? Just keep that in your mind. Now, what we're going to do is I'm going to show you, you already saw the first homing. I'm going to take mine and put it back to normally the way I have it. And this is a bug, okay? In my opinion, it's a bug. When I change that Y, since I can't select B and they're supposed to be wired together, that needs to get jumped up. But maybe that's just how their software works. We hit save and you go back into homing, it's still going to be there, okay? It doesn't happen until you go back to the programming MDI and then hit machine ready. Double click on it. That will home, where you can sit there and hold it for 3 seconds. Yeah, that doesn't work. That's what's in their manual. But now they'll both be there. Y and B will both be checked. Alright, so what does this look like when you get it? So if you go down to jogging, and we go down to continuous mode, and I'll get into all this stuff here in a little bit. We move this over, we move this back. I don't have any bits in here. I'm going to drop this down some. And now I hit the machine ready. See how Z comes up. And then you're going to see it's going to move on the Y axis and the X axis simultaneously. Now the Y-axis is done, now the X-axis is done, and we are homed. At this point in time, you can zero all of these guys out. Alright, this is your machine location, actually 0.2504 and 0.508. You're just going to have to deal with the extra thousands or hundreds of thousands or 10 thousandths of an inch out there, or millimeter or whatever it is. But the jogging and probing to zero marks everything to zero. This is just easier for you to keep up with. We'll get into this in a bit also. Alright, so that's how you home your machine. How does homing actually work? Like, how does it know to come home? How does it know to stop? Those are the sensors that are sitting on each of your axes. You have the Y, the B, and the X axis. There are sensors there. And inside of the setup area is where they reside. And I will show you how they work here now. On the setup screen, if you scroll this guy down in the middle, you're going to see something that says X home sensor, Y home sensor, B home sensor, C home sensor. Alright, so become very familiar with those guys and also your probe. Now these are all set to low because when the sensor is triggered, it'll jump to high, just like this guy says. Alright, so let's figure out how that happens. So back here we have the Y sensor. In my hand I have just a regular old small screwdriver, nothing major. I'm not probing anything, I'm not sticking my fingers in here, I'm not going to get electrocuted. We're just going to break the beam. There we go. So when I break the beam, the Y home sensor goes high. Alright, so there's a little piece of metal back here, right here, that it comes in and goes into this little hole, and when it does, it doesn't actually touch anything. Find a hole, there we go. It doesn't actually touch anything, it just breaks the beam. And when it does, then this triggers high and it tells the computer controller to stop bringing it in. So there's a little light in there, and if you look down it, you can see it. But you're just going to break that beam and it's going to go to high. Every one of these, the X, the Y, and the Z, they all have one. So once this guy homes over here, once the homing is done, remember I talked about the pull-off distance in the screen. That's what the pull-off distance is. Once it hits and says, hey, I'm homed, it's going to move back away. So it's going to come into the slot like this, boom, trigger, and it's going to back off. That's what the pull-off distance is. So that's how that works. Probing is basically the same kind of thing. So if I just take my probe, here's the probe, and I touch these two together, see how it turned high? So that tells the computer to stop probing and read that information. So on that note, let's move over to probing. In order to do probing, we need to switch on to jog and probing. Now you're going to see there's an alarm Y hard limit when you do this. Do not freak out about that. That's just because you've hit that limiter a couple times and turn it on. So we're going to hit double tap to go home, and that will clear that alarm out. Alright, so that's all good. So from the setup screen, we move over to probing, and this is what probing looks like. Right now, this would normally be blank, but I've got an application loaded for the probing. So, how do we probe? Well, the first thing we need to do is we need to get our machine lined up with the probe. And what I mean by that is your probe's going to set on the bottom left corner of your board. Now you can do this in the center, the bottom right, the top left, or the top right. I do the bottom left because this is where my 0 is for the machine, and it's easier for me to correlate this. So the first thing you need to do is you need to get this little guy back here, bring it down. Now you want to be between the surface of this wood, your wood, and the top of this, because the side of this bit has to touch here. Alright, so we're going to bring it close so we can see it. And what's going to happen is this is going to come up, it's going to touch, it's going to go to the side, it's going to come down, and it's going to come in and touch on this side. And that will set your X and your Y. Alright? And then we'll adjust the Z up, bring it over, and we'll set it down, and that will do your Z. So I'm going to run through this first, and then I'm going to show you how to do it on the screen, because going back and forth really is a pain in the butt. So always connect your magnet. Otherwise you don't get the current. So right now this is an open circuit and you need that current to go through here, touch this, and touch here. So I'm going to go in and sense this. And then it goes over to the side. And then what we'll do is we'll raise it up, move it over, and then we'll pick up the height, the length of the bit. And that's it. That's all probing looks like. Now, we're going to do this again. But we're going to do it showing you the screen. So here is the probing screen. Now, what did all these boxes and stuff mean? Well, the top of this means we are looking at what is the diameter of my bit that I'm going to probe with, what's my feed rate, where's my X offset, Y offset, and Z offset. These settings have to be saved before you do anything on the bottom. Okay, so simple enough. How big is the bit that we have in there? Well, it's 1/4 of an inch, so that's 0.25. And if you don't know that 0.25 is 1/4 of an inch and that 125 is an eighth and 0.0625 is a 16th and 0.03125 is a 32nd, trust me, over time you will know these numbers. If you're doing imperial, if you're doing metric, I don't know what to tell you. 5 millimeters, 6 millimeter, 10 millimeter, whatever. So you'll learn those numbers too. The X offset, Y offset, and Z offset, those come from your probe. So your probe, my probe sits against my board like this. This circle is the corner on my bottom left corner. So this would be the X direction, this is the Y direction, and this is the Z direction. Alright? So when we measure the X direction, you have to turn this around and measure from this side, this inside wall here, to the outside of this. And for me, that's 2.13250. And for the Y offset, it's from here, the inside of this one on the bottom, up to the top, and that's 2.125 for me. And the Z offset is the thickness of this, which mine's 0.59. Do not take those numbers that Onefinity sent this to you and take them as being gospel. Mine were off a little bit than the original numbers, and it could be because someone used a different probe than the one I have. I mean, they are machined, they're not 100% perfect, they're going to be off thousandths of an inch, but it all depends on how meticulous you want to be. Once you get all your information in, you need to hit save settings. Alright? Simple as that. Now, I have it set up the way I did before, and I'm going to turn down here and show it to you. It's sitting right there. And so what I did is I wanted it to touch on this side, go around. You can see the little arrow go around, come down, and come back and touch on this side. So that's pressing this little dot here. If I just wanted to do the X, or rather the Y, I would just press the center dot. If I wanted to do the other side, I would press this center dot. If I want to do the X, I would press this center dot. If I want to do the negative of the X, I would hit this center dot. These guys take care of all of the edges on the corner, so it will take care of both the Y and the X respectively. So right now we're running it, and you can see up here at the top the numbers are moving because that's finding where my X and my Y are going to be. So okay, now I bring up the Z, I scoot it over like that, bring it down a little bit. It doesn't take a long time. Maybe. There we go. And hit that. Boom. Touched off and we're done. Now what I can do at this point, I am looking at that I am 0.6599 above the top of my board. So since the top of this, go down here, and you can see I'm pretty daggone close to that probe. Alright? If we were to zoom in on that probe, I am really close to the top of that. Alright? So if you look at these numbers here, and the top of my Z offset's 0.59, and the top, where the bottom of that bit is 0.6599. My 0 for Y is 1 inch 0.19. It's almost a quarter of an inch from the front of the board to the back this way. So like if this is the front corner of my board going back away from me, it's 1.19. And for the X, it's 1.55, so it's about 1.5 inches that way. And that's all I really care to know about at this point in time with the probe. One thing I want to mention right now is once this probing is done, G54, alright, if you hit G54, you're going to see this is going to stay at the top at 0.08, 0.04, 4.9. I hit G55 and notice this went to 8.32, 2.97. Those numbers are matching what's on the machine for the X and the Y. Gotta click off of that. Back in there. So those numbers match exactly what's on the X and Y. Now, why does G54 have these other numbers? G56 is the same, 7, 8, 9, right? So G54. So if you go to Tools and Offset and you look at the bottom here, these are worksite work offsets. So your G54 should say work origin. This should say work origin. I'm going to see if I can just type in work origin. Work. And we're going to hit that as save. Now you notice these numbers are 8.32, 2.7. Everybody else is 0. So when you come back here, if you hit your G54, you notice this is a negative 0, negative 0, 4.9, whatever. If you were to subtract these numbers from the machine's current position, you will end up with the numbers down here in the G54. Alright, so 0 minus the 4.9, 4.93, you'll end up with that number. If you subtract the numbers that are in G56, which are all 0, from the machine location, you're going to end up with the machine location 57, 58, 59, all the way across. So this is the tool offset of where the machine is actually at. Alright? So the first thing we need to do is we need to run a program, and this is the output that I have for the carve code. Then underneath Lars's workshop is the actual code that I run. The way that we run this guy is we go to programming and MDI. Now, the first thing you need to do, because right now you have got a spindle that is sitting out in the middle of your wood. Alright? You never want to start an application like that. So the very first thing that I always do is I hit go to work origin. Now you see what that did? That brought you all the way up to where 0, 0, and then brought Z as far up as you can go. Now that is what the work origin is. So the next thing that needs to be done is you need to go to jump to line and make this 1. And then hit start from line. And then hit exit. I've tried hitting rewind and sometimes it works, sometimes it doesn't. I find that once I run a program and hit rewind, it does work. But if I'm first getting into it, it doesn't work. And it just usually comes down and hangs like right around here. So this runs, this little program that I ran took my 0.25 and made the T4. So right now it's going to say tool 3. So when I run this thing, we're going to hit cycle start. It's going to tell me put the bit in. Well, the last tool that was running here was a tool 3. Okay, that was a 1/8 inch bit. As you can see, that's not a 1/8 inch bit. So I'm going to hit the cycle start again, and then you're going to see this thing barely skim the top of this piece of wood. It's going to move out to where I told it to go. It's going to lower itself, to 0.2 inches, the safety zone. Then it's going to stop. Then the spindle will start up. And yeah, there's a little bit of noise with the spindle today. I don't know why. And that's it. That's all I wanted it to do. So I just want to cut one straight little pass, and then it will come up and it will get out of my way. Now, so in the application that I use, which is Carveco for this, I drew a line that came straight down like this, and what I did is I said, give me a profile on the outside. Now, in Carveco, a profile on the outside is either the right side or it's the outside of a circle. Now, if I was to just switch out this bit now and put a 1/8 inch bit in here, thinking that it's going to come down the side of this, it will not. All right. It's still going to pick up. Remember, my probing, my diameter was the 1/4 inch across here. Right? Was the 1/4 inch across the tip. So it will actually run that 1/8 inch dead down the center of this. Right down the center. So if we had an 1/8 inch bit, which I got one laying here, it's going to take the center of that and the center of this and line them up. It's not going to take it off the edge, it's taking it off the center. That's why the diameter is important on the probe. So I'm going to pull this out and put it in, and I'm going to show you this run. It'll just come straight down the center of here. So say I had some detail work that I wanted this 1/8 inch bit to cut out for me. Like say there was some detail in a turn, or you know, something like an ear, and I needed to get up in this little pot. I can't just rerun the program with the 1/8 inch bit. So there's the 1/8 inch bit, and I'm just going to rerun this program again. So I'm already at work origin. I'm going to hit rewind. Going to go back to line 1. And then this thing's going to run. Now watch where the bit lands. Notice the bit's higher off the ground because I haven't done any probing with it, and the 1/4 inch bit was actually longer. Now it's going to come down, it's going to think that it's hitting it, but it's not. So how can we rectify this? I'll show you here in a second. So in order to get this to even cut, you would need to put in your probe, come back to probing, just like we did before. Make sure your magnet's on, and then hit your middle probe button. Now I've got the proper height of that bit. So now when I go and I run, need to go to programming, I need to go back to my work origin. Remember that. Need to go back to jump to line, get it back to the beginning, and hit cycle start. Now watch how far down this will come. So that's looking a little more promising. So that actually cut, but notice it was dead center down where the 1/4 inch is, and we wanted it to be on the left hand side. In order to get something in the left hand side, you need to run another file. So this one is the 1/8 inch profile update. So what's the difference between the two? Really, there's not a lot of difference. Okay, when you're looking down at the code, you're not going to be able to tell a lot of differences. It seems it's going to take the same path and everything else. The difference is your X is going to be kicked over because you told the program you're using an 1/8 inch bit instead of a 1/4 inch bit. Therefore, the program took the diameter, or the radius more specifically, of the bit and adjusted it for you. Now, when I go to jogging and probing now, I don't have to do anything because I've already set the height of my bit. Remember before, this was like 0.69 whatever. This is a considerable bit shorter than the other bit. Considerable amount. So all we need to do now is go back and jump the line and then hit start. Now it's going to tell you you need to change to the number 3. Well, we already did, because before, remember, we changed the bit. So when it comes down, it read this program and said, oh, you need to be on tool number 3, which is a 1/8 inch bit. So now let's watch where it cuts. See, now the bit is no longer in the center, it's on this side, it's on the left side. Those are the ramping moves, and now it came down the left side very clearly. Right, so we've dealt with homing, we've dealt with probing, we've dealt with switching out a bit. And how to do that properly by, you know, having a program that runs for your 1/8 and your 1/4, or 2 different size bits, and having a proper program for it. The last thing that we're going to cover is the feed hold or the escape, and hitting that little red button on your screen, and simulating if we broke a bit. All right. I've only broken one bit. It's been a 1/32 bit on my Onefinity, but I hear people break them all the time. So this is something that I think everybody should know about. Again, simulate this for yourself. Don't go out and just break a bit. They're expensive unless you get them off a Drill Man on eBay. Okay, Drill Man 1 is where I get mine. Pretty reasonable price. So if we need to switch out a bit, it's not as hard as you think it is. It's a lot of what we've already done. The hardest part is making sure you start your program back where you can. All right, so let's go check this out. Okay, so we're gonna run this program here. So I've added a couple steps to it because, you know, just re-stopping it here and dropping it back in really wouldn't make any sense. So we load that back here, go to work origin, which we're already at. Going to hit rewind, and we're going to start this guy up. So this guy's going to cook across here. I apologize, but I started recording. I started this process and didn't hit turn on my recorder. So once we make the turn, we're going to simulate breaking the bit. So right there, say we broke the bit. Okay, you can need to know exactly where you're at this point in time. So I'm going to raise this up, and my Z is at 0.1246. Okay, and then I'm going to turn off my spindle. Now, if you had broken a bit, the Z, raising it, knowing where it was at would be very important, but you could turn the spindle off because the spindle's not touching the wood, but mine is touching the wood and I need to replace it. Replace the spindle. So we're simulating replacing the spindle, and the X is at 2.1835, and the Z is at 1.4626. Now, those numbers are right here. That's what I'm taking down. Now, my Z is now at 0.4867, but it was at negative 1.246, and that's very important to know. All right? So now say we go and we changed out the bit, so I had to go to work origin, right? I had to reprobe with the new bit. So you need to put your new bit in, you need to drop this down on here, and you need to reprobe it. Jogging and probing. So we're going to bring this guy down like this. We're going to find out where it's at. It's because the new length of bit, right? That's the whole thought behind it, at least. And we're coming down, getting a new probe. Now, we get this guy out of the way. We exit probing. We go back to here. Go to work origin. Now, we need to get back to that point. So the 1.586 is this line right here, and the Y of 1.462 is we're moving from here down to here. So we moved out to 1.586, 4.056. We're going to stay on that 1.586. So this is your travel down here to right this point. So at this point, we started moving this way. All right, so where we actually broke the bit was saying here. All right, so you need to resume this application. So we're going to resume it here on line 21 because that's, you know, makes more sense. So we're going to start from there. So this tells you your work X position is going to be this, Y, Z, A. Your feed rate is going to be 30. Spindle clockwise. So the first time I did this, I thought, oh my gosh, this thing's just going to like fly to that spot and it's going to crash and that's going to be the end of everything. And actually, it's not. So I'm going to go to jog and probing and push this back over here somewhere. So I'm going to show you what's going to happen. I'm going to bebop back and forth between them. So you need to jump to code number 21 and then you need to hit run. Now, here's a very important bug. Multiple cycle start presses required to resume job. Each cycle start press will move an axis as required. Final cycle start will resume the cut. So you hit this and then you hit. Now I'm just going to keep on tell you when I'm hitting a cycle cut. So that just moved the Y axis. I'm going to hit this again. Now just drop the Z and then say let's resume. Now I hit this again and it's going to take off. There we go. So that's in case you had a bit break. That's the steps you need to go through to finish it off. Now my application does this. It raises it up and brings it out of the way. This is to make sure that, you know, your hands aren't here. You might have had to clamp something into this spot, you know, a variety of different reasons, but I think it's safer. So I hope everything that we did today in this video helps you out. I hope it wants you to get in and say, okay, I want to go test that out. I want to try that out. Buyer beware, you might break a bit. There is possibility anywhere along the way of doing anything on your CNC machine, you can break a bit. If you like the video, please click like. If you like this kind of stuff, please subscribe to the channel. It actually keeps me coming out and wanting to do more videos like this for everybody. Other than that, have a great day. Come back to the workshop. See you again.